Before we begin the video, we have an important announcement. We have a Discord server now. The link is in the description, but you better just join the official OA Discord server instead. Disclaimer: this video has a very high likelihood of becoming outdated in the near future due to recent scientific developments and the decision that massless monopoles are no longer canon to OA due to their unrealistic nature. Subatomic particles. These are amazing little things that are everywhere. Imagine if there were no subatomic particles. We would be dead. We would cease to exist. However, there are certain types of subatomic particles that we don't need to survive, but are very useful in modern technology, such as magnetic monopoles. What are these magnetic monopoles? First, we have to know what monopoles even are. Monopoles are like knots in the fabric of the universe, which formed when the universe was cooling. Imagine you have a pot of molten lava and it cools very fast. Crystalline structures start forming in different regions inside the pot. The structures trigger nearby atoms in the fluid to also settle down and attach into the pattern. However, when different crystallizing regions meet, they are each crystallizing in a different way and orientation, and they are cooling too fast to connect with each other. This creates separation points between the different regions, each with different disconnected patterns. These patterns would have different crystalline structures, and so you would have to remelt the whole pot in order to fix the defects. Now, imagine this pot is the entire universe, and when the universe cooled billions of years ago, it was separated into different regions which caused defects in the fabric of space-time. It caused defects in something called the Higgs field. So, what even is the Higgs field? Well, imagine you are swimming through a viscid fluid with other people. Some people have more trouble swimming through it than others. The Higgs field is like this fluid, and it is everywhere in the universe. The more trouble you have swimming through it, the more mass you have. This is how objects in the universe have mass, and so monopoles are basically defects in this field. There are different types of monopoles. Some are known as dyons, which carry both electric and magnetic charge. Some monopoles can even be as massive as an amoeba. Monopoles can stick to protons or neutrons and then break them apart, releasing a positron and turning the proton or neutron into a special type of particle called a pion. But we are here to talk about a special type of monopole, which is known as a magnetic monopole. These are monopoles which carry only magnetic charge. What does it mean when we say they carry magnetic charge? Well, imagine cutting a bar magnet in half. When you do this, you will not get a north side and a south side. Instead, you will get two separate magnets, each with their own north and south poles. But what if there's a particle that was only north or south? These are magnetic monopoles. They carry units of magnetic charge, and a north monopole will annihilate a south monopole, kind of like matter and antimatter. Monopoles are like tiny bombs, which can catalyze fusion reactions and create explosions, so there cannot be that many monopoles in the universe, or else we would have noticed these flashes. Many civilizations instead look for monopoles inside gas giants or neutron stars, but they have found nothing. But if monopoles have never been found, then how are they used in technology? They are created. You can even create your own monopoles at home. It's home experiment time! All you need is a particle accelerator the size of a planet, large enough to break the symmetry of the universe and create defects. Pause the video for a few minutes and come back when you have the necessary materials. Done? Great! Now you can create certain special monopoles that are used to catalyze fusion reactions. Make sure to be careful. Now, for our next home experiment. This experiment will require the guide of an S3 or higher. Alternatively, you could ascend to an S3 or higher now, if you are not already. Also, you'll need temperatures of 10 to the power of 27 Kelvin. We will give you another few minutes to do that. Are you done? Hooray! Now, you need to use you or your Architect's deep understanding of supersymmetry, aka SUSY. Now, you can create monopoles using the temperatures of 10 to the power of 27 Kelvin. But these are not monopoles like the ones before. The ones before were unstable. These ones are stable. You can still catalyze fusion using these, but you now have access to new super cool weapons, such as bombs. These bombs are even better than antimatter bombs. They last longer, are more deadly and are easier to control. They basically catalyze fusion really fast. Antimatter bombs waste lots of their energy on muons, but monopole bombs do not have this flaw. So, buy our monopole bombs today. Do not settle for a competitor's weak antimatter bombs. Magnetic monopoles are basically tiny magnetic poles, so there is a much more straightforward use for them: magnetic fields. Compact, strong magnetic fields are very useful. They can be used to suck up hydrogen from the interstellar medium and launch it out again at very high speeds, powering spacecraft. Once you have monopoles, you do not need to go through the long process of creating them again. You only need a particle accelerator of 10 kilometers or more. Just smash 2 monopoles together and you can breed more. Now you can have many monopoles. With all these monopoles, you can create a material known as magmatter, which is super strong and dense and can be used for a wide range of technologies. Magmatter is everywhere, so much that the current era is often called the Magmatter Age. So, what is magmatter? It is made up of tiny particles called magatoms, which are just like regular atoms, but made out of magnetic monopoles. These magatoms are made up of magnuclei and magtrons, which are analogs of nuclei and electrons in regular atoms. Both magtrons and magnuclei are made up of a magnetic monopole and a neutron fermion. Magtrons only have a magnetic charge of +1 or -1, though magnuclei can have much larger or smaller charges. Most magnuclei used have magnetic charges between +1 and +12. Magatoms can form from both a combination between magtrons and magnuclei, or a combination between a positive and negative magnuclei. However, most magatoms used are a combination between magtrons and magnuclei. Magatoms can be 300 million times smaller than regular atoms. Because of this, magmatter is extremely strong and dense. Typical magmatter is 2 million times stronger than regular matter and has a density of 10 to the power 33 kilograms per meter squared. That's a lot. Magmatter chemistry uses different mechanisms than normal chemistry, and these mechanisms are very advanced. Also, the temperatures required to melt magmatter are very high. So, magmatter is mostly only able to be used by high transapiens or argolecs. Magmatter is usually formed in a string or coatings, as too much magmatter in one place, such as in a magmatter crystal, amorphous solid or liquid, would be dense enough to collapse into a black hole. There are special types of magmatter, such as magcarbon. Magcarbon is used to describe magatoms that form tetrahedral bonds with 4 other magatoms, just like carbon in normal matter. These magcarbon atoms can be made into magpolymer bucky tubes and maggraphene. Normal matter doesn't interact with magmatter like it does with other matter. When someone puts their hand on a table, their hand does not go through the table because of the Pauli exclusion principle, which prevents the electrons in the hand from occupying the same space as the electrons in the table. However, magmatter can occupy the same space as regular matter and can even pass right through it. Magmatter can even pass right through neutronium, one of the densest materials made out of quote-unquote normal matter particles. Also, magnetic monopoles do not have an electric field, so they do not interact with electrons. However, magnetic monopoles can interact with normal matter through magnetism. Diamagnetic matter and superconductors repel magnetic monopoles, while paramagnetic and ferromagnetic matter attract them. Something important to note is that magnetic monopoles tend to stay away from atomic nuclei and core electrons, since those are mostly all diamagnetic. Another thing is that when magnetic monopoles merge into magatoms, they become magnetically neutral, and usually do not interact with normal matter. However, magatoms and magmolecules may have magnetic dipoles, so they may still be able to interact with normal matter. Many magmolecules are specifically designed so that they will interact with normal matter. Magatoms with differing magnetic charges are placed about an atom apart from each other. The different charges cause a dipole and allow the magmatter to be anchored to ferromagnetic materials. GUT monopoles can break down normal matter, but monopoles found in magmatter do not have this property, and so can be combined with normal matter. Many materials are a mix of normal matter and magmatter. However, if you make a sheet out of magmatter called maggraphene and pass it through an object, the nuclei within the object may hit a monopole and disintegrate. Electromagnetic radiation interacts with magmatter in different ways than normal matter. Electromagnetic radiation has a magnetic field that can push and pull on monopoles. This can produce gamma rays. If magmatter is a magnetic conductor with free to move magnetic charges, it will be very reflective and reflect most electromagnetic radiation. Magmatter materials that are magnetic insulators, on the other hand, will be transparent and allow electromagnetic radiation to pass right through them. So, what is magmatter used for? Magmatter is used to hold megastructures together through cables and braces. It is also used to coat objects and protect them from damage. Since mag atoms are so small, even smaller than atomic nuclei, they can be used for a very special type of technology known as Pico technology, which is basically extremely tiny machines. However, it is hard to get magmatter technology to work at normal temperatures, which are basically like absolute zero to magmatter. However, with enough energy in the environment, these devices can even self-replicate. Magmatter computing is way faster than computing using normal matter due to the small scale of magmatter and, by extension, the speed of mag chemistry and magmatter interactions. Finally, there can even be life made out of magmatter. An architect in the Perseus arm in a system known as the MagVV system hyperpolity created 8 biochemistries of magmatter life that live inside a torus. The organisms are all less than 15 nanometers in size, and the biosphere is diffuse to prevent singularities from forming. In 9310 AD, a ship from the Perseus Arm Defense Organization investigated the system after a mysterious megastructure was discovered there and contacted the local architect. The star was an A-type star, which was surrounded by a Dyson bubble 0.3 AU away, which beamed energy to a J node in the torus, which has a major radius of 2.4 AU and a minor radius of 1.5 kilometers. Eventually, a civilization of softened magmatter creatures emerged in the torus and self-modified and pro-evolved, creating thousands of clades. Since the torus is so expansive, and magmatter life is so fast and small, the torus has a diversity equivalent to a Sephirotic empire. They were even able to breach the first toposophic level. To the organisms, the rest of the Terrigen sphere is extremely slow. The torus is mostly peaceful. However, there was a 100 nanosecond war in Copernicus 9385 over 15 cubic centimeters formed by a misunderstanding. Eventually, the system was connected to the Nexus wormhole network, and in 9642, they joined the Techno-Rapture Hypernation. Well, that's all for now. This video is getting pretty long, so we'll talk about conversion technology later. Thanks for watching, everyone, and coming on this journey to learn about magnetic monopoles. And goodbye, explorers. Shh.